In today's video, we will see how the magnetic field of Earth is generated with some interesting facts and how these fields are important for life to exist. Let's first understand how Earth's magnetic field is created. Earth's interior is generally divided into three major layers: the crust, the mantle, and the core. The core is further divided in two parts where outer core is liquid while the inner core is solid due to immense pressure from above layers. The core mostly contains the metals iron and nickel. One can think that the inner core is the main reason for the magnetic field, but this is not true because the temperature of inner core is around 5200 degrees Celsius, which is way more than the Curie temperature of iron and nickel. And in physics, Curie temperature is the temperature above which metal loses its magnetic properties. So the most accepted theory is the dynamo theory, which says that most of Earth's magnetic field is generated in the fluid outer core. The convective motion of molten iron due to heat, along with the Coriolis effect caused by the overall planetary rotation, generates electric currents in a specific pattern. This Coriolis effect is the same effect that produces hurricanes on Earth's surface. So these electric currents in turn produces a magnetic field. The magnetic fields produced are quite complex, but the overall effect is similar to a giant bar magnet placed inside the Earth. The magnetic field extends out in space and covers a vast region around the Earth. This region is called magnetosphere. The magnetic field is extremely important to sustain life on Earth. Without it, we will be exposed to high amounts of radiation from the sun and our atmosphere will be free to leak into space. This is what likely happened to the atmosphere on Mars. Scientists believe that earlier Mars had a magnetic field similar to Earth, which protected the Mars atmosphere and its water bodies. But Mars' magnetic field got weakened in past, allowing for its atmosphere to be stripped away by solar winds. Now coming back to Earth's magnetic field, there is a big misconception among many people. We all know that the north pole of compass needle points north, but we also know that like poles of two magnets repel each other. So actually the geographic north pole is the magnetic south pole of the Earth and the geographic south pole is the magnetic north pole. At many places this is not shown correctly. Also, the Earth's magnetic axis is not quite parallel to its geographic axis, so the compass reading slightly deviates from geographic north pole. There are some places on Earth where the magnetic field behaves differently, but the fascinating fact is that geological evidence shows that Earth's magnetic field reverses direction entirely at irregular intervals between 10,000 to 1 million years. One of the ways scientists figure this out is by studying the lava rocks. We know that since Earth is formed, hundreds of volcanic eruptions occurred. When erupted molten lava freezes, it locks the magnetic orientation of metals at that time. By studying the variation in several rocks, scientists discovered this phenomenon. Now, some questions may have arrived in your mind, like will flipping of magnetic field cause catastrophic events on Earth, and when will next reversal occur? So some theorists say that the magnetic field reaches zero before complete reversal, which will lead to penetration of solar radiation and which will destroy life on Earth. So let's go to NASA's webpage for finding the answer. See, here it says many doomsday theorists have tried to take the natural geological occurrence and suggest it could lead to Earth's destruction. But would there be any dramatic events? The answers from the geologic and fossil records we have from hundreds of past magnetic polarity reversals seems to be no. So the explanation for this is given below. The last time that Earth's poles flipped in a major reversal was about 7,80,000 years ago. The fossil record shows no drastic changes in plant or animal life. It also says while Earth's magnetic field can indeed weaken and strengthen over time, there is no indication that it has ever disappeared completely. A weaker field would certainly lead to small increase in solar radiation on Earth, as well as beautiful display of aurora at lower latitudes, but nothing deadly. Now another article answers the second question. Such reversals recorded in the magnetism of ancient rocks are unpredictable. They occur at irregular intervals averaging about 3 lakh years. The last one was 7 lakh 80,000 years ago. Are we overdue for another? No one knows. Another fascinating fact is that in recent years, the magnetic pole near the geographic North Pole is shifting approximately 55 kilometers per year from the Canadian Arctic towards Siberia, which was earlier shifting by just 10 to 15 kilometers per year. Now, is this sign of magnetic field preparing to flip? Actually not. It is true that sudden increase in movement of pole is seen, but we know that the field can fluctuate quite a bit even it is not about to reverse. So there is no need to worry until a lot more changes are seen. Now let's see a beautiful thing which these fields have given us. The magnificent auroras visible near the north and south poles at night. An aurora is a natural light display that shimmers in the sky. Colorful blue, red, yellow, green and orange lights shift gently and change shape like softly blowing curtains. The activity that creates auroras begins on the sun. The sun is a ball of super hot gases made up of electrically charged particles called ions. The ions which continuously stream from the sun's surface are called the solar wind. As the solar wind approaches the earth, it meets the magnetosphere. Most of the solar wind is blocked by the magnetosphere, but some charged particles are trapped in Earth's magnetic environment and are then moved in a region of atmosphere called ionosphere. In the ionosphere, the ions of solar wind collide with atoms of oxygen and nitrogen from the Earth's atmosphere. On interacting with the particles, the oxygen and nitrogen atoms get excited and emit photons. The wavelength of the atom's photon determines the color appearing in the sky. Excited nitrogen atoms produce blue and deep red shades, whereas excited oxygen atoms are responsible for green and red colors. The overall effect of these colors is what creates the northern and southern lights. Now before ending this video, there is another amazing fact for you. Now we know that magnetic field of Earth takes at least some thousands of years to flip. But you would be surprised to know that Sun's magnetic field flips every 11 years. Yes, you heard it right. The Sun's magnetic field reverses its direction in just 11 years. So the Earth's magnetic field, which is protecting the atmosphere for millions of years, is one of the reasons for the existence of life on Earth. I will be coming with more such videos. So if you like it, do give it a thumbs up and share it with your friends. And do subscribe and press the bell icon to get notified whenever I drop a video. And thank you for watching.